Hello, everyone. Welcome back to 10 Days of Python with Artificial Intelligence. In this module, I'm going to explain an essential tool for any developer, Git. We'll learn what it is, how to use it to manage your projects, and how to collaborate with others using platforms like GitHub. To start, if you're on Windows, you'll need to install Git Bash, which provides a Git-compatible command line environment. If you're using a Mac, Git Bash usually comes pre-installed, so you can skip to the next step. To install it, go to the official Git for Windows website and download the installer. Run it, accept the license, and during the installation, make sure the Git Bash option is selected. For most steps, you can accept the default options. To confirm that it works, open vise.cloud. If you need a guide on installing vise.cloud, you can watch my previous video. Go to Terminal and GT New Terminal. Click the shell selector, usually a drop-down menu next to the plus sign, and select Git Bash. If you see the $sign, you're good to go. To make it your default terminal in Windows, open the command palette, search for Select Default Profile, and choose Git Bash. Version control is critical for application development. Imagine you're writing an important document or piece of code. You make changes and save a version. Then you make more changes and save another. But what if, oh no, you mess something up badly and can't fix it? Version control allows you to save and compare copies of your work over time, and Git is the system that manages this. If something goes wrong, you can easily roll back to a previous working version. You can even compare the current version with any previous version. We're going to use Git locally on your computer. Open your terminal and navigate to your project folder. To initialize Git in this folder, type Git in it. This creates an empty Git repository and a hidden Git folder that will track changes. This folder is now your working directory. Git uses a staging area. It's like a bin where you place the files with the changes you want to save for your next commit. Use Git status to see the status. New files that Git sees but isn't tracking are displayed in red. To start tracking changes to a file and add it to the staging area, use git add and the file name. To add all new or modified files, use git add. Git status will now display them in green, ready for commit. To save changes from the staging area to your local repository, run git commit, m, and your message. The commit message is vital for describing the changes. Ideally, it should be clear and concise in the present tense. To view the commit history, use git log. You'll see each commit with its unique identifier and message. Head tells you where you are. If you modify a file and mess it up, git status will show you that it was modified. You can see what changed with git diff and the file name. To discard those changes and revert to the last committed version, use git checkout and the commit name. Git isn't just local. You can also have remote repositories, copies of your project hosted on servers on the internet, like GitHub. Go to github.com and create an account if you don't have one. On GitHub, you can create a new repository. Give it a name and don't add any files. You can choose public or private. Public is great for sharing and collaborating. GitHub will show you commands to connect to your existing local repository. In your terminal, inside your project folder, use git remote add origin and the URL of your repository on GitHub. Origin is the standard name for your main remote repository. To push your local commits to GitHub, use git push script or origin main. Script or link your local branch to the remote branch. Your project and its history are now on GitHub. There are files you definitely don't want in your repository, especially a public one, like passwords or secret keys, or local configuration files like ds_store. To tell Git what to ignore, we create a special file called gitignore in the root of our project. It's a hidden file. Inside gitignore, simply list the names of the files or folders to ignore, one per line. For example, secrets, txt, or ds_store. You can use hash for comments and asterisk as a wildcard. For popular projects, there are ready-made git ignored templates on GitHub. Once you create and configure your gitignore, Git simply ignores those files when using git add or when making commits. They won't appear in Git status as files to track. This is crucial for security and keeping your repository clean. While git push sends your local changes to a remote, git clone does the opposite. It downloads a complete copy of a remote repository to your local machine, including its entire history. This is super useful for getting the code from open source projects, whether to use, study, modify, or contribute to them. You can find the URL on the repository's GitHub page. You can clone games like Quake or Wordle and run them on your computer, exploring how they work. Your main line of development in Git is called the main branch. But we often want to work on new functionality or experiment without affecting the main stable version. That's what branches are for. A branch creates a starting point for development separate and parallel to the main branch. You can commit to your new branch without modifying the main branch. This is the way to manage the introduction of updates in large software projects. To create a branch, type git branch and the branch name. To view your branches, type git branch. To switch to a branch, use git checkout and the branch name. When you switch branches, the files in your working directory are updated to show the status of that branch. If you finish work on your branch and want to merge it into the main branch, use git merge. First, make sure you're on the receiving branch. Git checkout main. Then, merge the other branch by running git merge and entering the name of the branch to merge. Git will merge the changes. Sometimes, if changes are made to the same part of a file, merge conflicts can occur, which you must resolve manually. After merging, your main branch will have the changes from the other branch. How do you contribute to a project on GitHub that isn't yours? You don't have direct permission to git push. The way is by using forks and pull requests. First, you make a fork. This creates a copy of someone else's repository under your GitHub account. You are now the owner of this copy. You clone your fork to your local machine. You make your changes, commit them, and push them to your remote repository. To have the original project author see your changes and consider them, you create a pull request from your fork to their original repository. It's a suggestion for changes. It's called a pull request because it's the original author who must pull your changes from your fork. The author will review your pull request. They can comment on it, ask for changes, and if they agree, they will merge your changes into their main repository. Your contribution is added to the original project. Forking and pull requests are the standard way to collaborate on the vast majority of open source projects on GitHub. It's a great way to learn, practice teamwork, and contribute to the community. And that's a summary of the basics of Git and GitHub. Now I'm going to show you a real-life example of how I resolve a bug in a public repository and make a pull request to the owner. It's the Code Video Generator library, which is used to produce explanatory programming videos. The first thing I do is create a fork so I can edit it in my GitHub account. The agent I'm going to create was published by Google this week and is called Jules. You have to connect Jules to the repository and authorize it to read and write. When I tried to run the repository on my computer, I got an error saying access was denied to one of the files. So I asked the Jules agent to fix it. I followed the process, and in just under 3 minutes, it has created a new branch, found the source of the error, and prepared everything to publish it on GitHub. I check in the changes and click Publish. The next step is to clone the repository and check that it works. Next, I create an environment and install the dependencies in the requirements txt file. When I try to select the branch created by Jules, I get an error message asking me to verify the repository. I resolve it by following the suggestion. Then I select the branch created by Jules. To run the repository, I have to install it in the environment by running pip install from the repository folder. The readme.md file on GitHub contains instructions for use with the commands to run the example file. I run it, and it works thanks to Jules. Finally, I make a pull request, with the message written by Jules and some notes on the tests I performed, and I leave it for the repository owner to merge. And now I'm done. We've seen how to control your versions locally, push your work to a remote location, ignore unnecessary files, clone other projects, work with branches to develop new ideas, and how to collaborate using forking and pull requests. Git is a fundamental tool in modern software development. I encourage you to practice these commands and explore the vast amount of open source code available on GitHub. It's the best place to learn and build amazing things. In the next few lessons, we'll explore some of these topics and other Git features in more depth. Don't forget to subscribe and tap the bell to receive notifications. See you next time.